Good day, my dear students. We have seen how to calculate Karl Pearson's correlation. We have seen how to calculate Karl Pearson's correlation coefficient. Coefficient of correlation for a bivariate frequency distribution. Sometimes the bivariate data may be actually ranks, say for x and y, if some marks are given or ranks are given, x1, y1, x2, y2 and so on, xn, yn, these are n pairs, and this xi's lie between 1 to n, distinct, and yi is also lie between 1 to n. They are not repeated. Xi's and yi's are not repeated. So these are ranks. Instead of just some values, these are ranks given, and the ranks lie from 1 to these ranks. Whatever, they may be two dancers or two singers, and they are given some ranks or given marks and accordingly given ranks, and none of them are repeated. So no repetitions. Then what happens is the values lie between 1 to n. Xi's are distinct. They are distinct. Yi's also are distinct. X and y is not repeated, that's what it means, not repeated. So xi is not equal to xj, when I is not equal to j, they are not repeated. Same applies for this. Then what is the rank correlation coefficient? That Karl Pearson's, what is the rank correlation? That's written as rho. This is called a Spearman's rank. Spearman's rank correlation coefficient. Coefficient of correlation. That was Karl Pearson's coefficient of correlation. It actually turns out to be 1 minus 6 times summation d square divided by n into n square minus 1. It turns out to be this much, 1 minus, and we prove this, and that's not difficult. If you use Karl Pearson's rank correlation coefficient, you get this. But you must know that these values are like, this could be 1, this could be 2, that could be n, 1, 2, 3, n, or it could be 5 here, 2 here, somewhere there would be 1, but all these values are there, and somewhere somebody could be 1 here, and 3 here, and 4 here, and so on. But all the values from 1 to 3, 1 to 3 up to n are there for x as well as for y. None of them are repeated, all the values are taken. Then what is the average of this values? What is the average of x bar? X bar will be same as y bar because they are same values, they may come in different order, they are same values. What is the average? You can calculate the average. That should not be difficult. What should be the average? This is the sum of all, x. Average is nothing but sum of all x divided by n. What is the sum of what is the sum of all these values up to n? This is given by n into n plus 1 divided by 2. But this is nothing but n plus 1 divided by 2. And these two will be equal because they are taking the same values, maybe in a different order, but they are taking the same values. So let me just repeat that. What are we doing now? We have done Karl Pearson's correlation coefficient. We have done Karl Pearson's correlation coefficient. Now we are taking special coefficient, correlation coefficient called the rank when these values happen to be ranks, if there are say two judges, if there is judge 1 and judge 2, and there are many students, 1, 2, 3, up to n of them, and they are given some ranks. Maybe this guy is the best singer, maybe that guy is not so good, and they are given ranks. If the ranks are not repeated, first we look at the ranks when they are not repeated. Then what is I mean, they take the same values, not exactly same here, but 1 may be here, 1 may be there, 2 will be here, 2 may be there. They are all same values from 1 to n, but not in the same order. Need not be in the same order. So, x2 could be 2, that could be 1, x3 could be 1, that could be x3 could be 1, and y3 could be 4, and so on. But the values all go from 1 to n, both the series, or both the series. In which case, x bar and y bar, the means will be equal, and they turn out to be n plus 1 divided by 2. What about sigma x? Sigma x and sigma y also will be equal because they are same values, not in the same order, but they are same values. You expect them to be equal, and they become something like n square minus 1 divided by 12. I know this because I have just now calculated it, and let's do it. That's not very difficult to do this. So that's not very difficult. Then we will show that this formula can be derived from Carl-Pearson's correlation coefficient. This formula can be derived from Carl. But these things we are going to use. But let's show this. So sigma x will be summation, sigma x square. Sigma x square will be summation x square divided by n minus summation x divided by n the whole square. And sigma x will be square. So there are n values. Summation of x square, so 1 square plus 2 square plus n square. And that you know is how much is that? That's n into n plus 1 into 2n plus 1. That formula increase with 1 divided by 6. So what you will get is divided by n here. So this is the formula. You get n into n plus 1 into 2n plus 1 divided by there's already an n and there is a 6 which comes, and n gets cancelled, and minus what you will have here is summation x will be 1 plus 2 plus n, and that is n into n plus 1 divided by 2, but there is a square, so that becomes n square, n plus 1 square divided by there is already a divided by n there, and divided by 4n, so 1n gets cancelled. You simplify this and you see that this becomes n square minus 1. How do you simplify? Well, let's do it. And that turns out to be, so you take 10 plus 1 out. You get n plus 1 out. I take a 12 out. If I take a 12 out from here, there must be a 2 on top. 2 times 2n plus 1. And if I take a 12 out from here, there must be a 3 on top. And if I put 12 here, that's what I'm doing. So there must be a 3 on top. So minus 3 times n plus 1. This is what you get, because 1 n plus 1 is gone out. And this is what I have. This is what you get from here. And then what do you have? You get n plus 1 divided by 12, and this becomes 4n plus 2 minus 3n. Square minus 3n. Is that right? Well, that's right. That is right. But, yeah. This is what you get. And right. Oh, yeah. yeah, this is n square. I'm so sorry because this is n and this also becomes n square. So n square is gone. There is no n left there. There is no n left here. Please take care. I made a mistake. Please take care. Please take care to see that I put summation x is this much. So if you this divided by n and square it. So this gets squared, this gets squared, this gets squared, and of course this comes down. This also gets squared. So that becomes n square, n plus 1 square divided by 4n square gone. Now that is a mistake I made. Okay. So what happens now is this is what you get, and this becomes actually n plus 1 divided by 12 into this becomes n minus 1, and n minus 1 into n minus 1 is n square minus 1 divided by 12. And that. So we have seen that x bar is equal to y bar, and that I had just now calculated was actually n plus 1 divided by y x bar was summation x divided by n, which becomes n into n plus 1 divided by 2n. So n plus 1 divided by 2. That's what we had. And sigma x and sigma y must be equal, as you can see, and this is what you get. These are the two values you get. Well, let me say that again. We had Karl Pearson's correlation coefficient. x1, x2, x3 were values, and they don't have to be, they could be anywhere. Say you could get 100 here, you could get 1 here, you could get 99 here, you could get 5 here, and you could get, say, maybe minimum is 20 or 200, and something like that, 150, and this could go up to 10. So these are, some of them may not be there, all of them 1 to 10 may not be there. All the values between may not be there. But now when you take ranks, if they are not repeated, they will come, may not in a line, may not be in a order, but they will be 1 to n. Say if there are 10 students, they will get ranks 1, somebody may get 5 first, somebody may get 2, somebody may get, if there are 10 students, these ranks will be given. Somewhere there will be 1 if there are no repetitions. They will be distinct. Similarly, you may get 1 and 4 and 5 and 9, somewhere 10 and then 9 or 8 or whatever. But you are getting, without any repetitions, 2 is here, it will be somewhere there. 5 is here, it will be somewhere there. 10 is here, it will be somewhere there. 1 is here, it will be somewhere there, and so on. All of them are there from 1 to 10, 1 to n. And in which case, they are distinct. They come without any gap, continuous. Then x bar and y bar must be equal because they are ranks, they are not repeated, they are from 1 to n. This is what you get as the mean, this is what you get as the standard deviation. Good. And now we got to show that the formula comes like this, but I didn't tell you what is d. When the variables are given x and y, and the values are given x1, y1, x2, y2, and so on, xn, yn, your d variable is nothing but x1 minus y1, x2 minus y2, xn minus yn. That's d variable. D is a variable. And d square becomes obviously so. D is nothing but x minus y. The sum of that. Because there is a sum here. Summation will be summation. But that can be written as summation x minus x bar minus y minus y bar. Well, if I do that, then, and I do square here, I do square here, I do square here, what do I get? I get summation x minus x bar. This becomes your summation d square. x minus x bar plus summation y minus y bar square minus 2 times summation x minus x bar into y minus y bar. Right? Yes, of course, right. Now if you divide by n here, and you divide by n here, and you divide by n here, and you divide by n here, what do you get? You get something familiar now. You get what you actually get is summation b square becomes divided by n, this is sigma x square, that is sigma y square, minus 2 times summation x minus x bar to y minus y bar divided by n. And if you divide by sigma x square, sigma y square, this will become 1. Okay. Now what happens, we also know that this is, they are equal. So this might, you might have to write sigma x square minus 2 times summation x minus x bar y minus y bar, and this is summation d square by n, because sigma x square, I have already shown that x bar is equal to y bar, sigma x is equal to sigma y, and actually I put sigma square is equal, and therefore sigma x also is equal. Okay. If you divide this by n times sigma x into sigma y, that's as good as divided by sigma x square. This will become 2 minus 2 times summation x minus x bar into y minus y bar, and that I am dividing by sigma x into sigma y. Well, but because sigma x into sigma y is same as sigma x square, because they are equal. Okay, good. So here I just divided by sigma x square so that I get this. Now you see, this I am saying is Spearman's rank correlation coefficient. Whether it is Spearman's or Karl Pearson's, it should have looked like that. Summation, oh, that's a divided by n, that's it. Sorry, that is a divided by n. That's a divided by n. I'm sorry, please put that n there. So this part, you see, that part, what I'm trying to tell you is Karl Pearson's, Karl Pearson's rank correlation coefficient was summation x into x bar into y minus y bar divided by n the whole thing divided by sigma x sigma y, because this is covariance, this is standard deviation. This is what it is. This n has been brought here, so it is this expression. This is r. Now I am putting rho because a particular because it's to do with ranks, but it's the same formula. So this guy should be that. Yeah. So that guy should be 2 minus 2 times rho. Is that right? That's right. Right. And you know, this is same as summation b square divided by n times sigma x square. But I told you sigma x square becomes n square minus 1 divided by 12. So if sigma x square becomes n square minus 1 divided by 12, I'll repeat this quickly for you. So what you get you get summation d square divided by n times n square minus 1 divided by 12. 12 comes here, becomes equal to 2 minus 2 times rho. Therefore, what you get is 6 times summation d square divided by n into n square minus 1. You see what is happening now. And therefore, rho becomes equal to 1 minus 6 times summation d square divided by n into n square minus 1. That's the formula. That is the formula, right? Let me quickly repeat that. I know that. So, from Karl Pearson's correlation coefficient formula, we get this Spearman's. It is the same as Karl Pearson. The only thing is we have special data here of ranks. And ranks being, continuous, a sequence of numbers without any gap. When there is no repetition. So if the ranks are from 1 to 10, all the numbers will be covered. All the numbers 1, 2, 3, 4, all the numbers will be covered from 1 to 10 without any repetition. When there are repetitions, we will have a look at it. So without any repetitions, if you do that, that's what happens with ranks. So if there are two series, if there are 10 singers and there are 2 judges, they give different number of marks, because they have their own personal judgments, which may not be exactly the same. So that can happen. So that can happen. It does happen. So my point is, let me quickly say what I have said. We want to show that Spearman's rank coefficient of correlation is given like this. But we are using Karl Pearson's. So rho we are writing actually as covariance of xy divided by sigma x into sigma y. It's the same formula I am writing. You see? But because these are ranks, xy are ranks, if there are n students, 1, 2, 3 students or participants, they are given some ranks. One may come somewhere here and 2 may go somewhere R. And so there is x1, x2, xn. And when there are no repetitions, they are given ranks. Here also they are given ranks y1, y2 by some 2 judges, yn. There is no repetition. Then I want to show the formula is like this. And how do you get it from here? First of all, we showed x bar is equal to y bar is equal to n plus 1 divided by 2, right? Yes, it is. Then we showed sigma x is equal to sigma y, we showed is equal to n square minus 1 divided by 12. I am not showing that again, but that's not difficult. Now from this formula, before I look at that formula, you know the d is x minus y. So summation d is summation x minus y, which I would like to write as summation x minus x bar plus y minus y bar the whole square. Well, why is this equal? I mean, if I write d square, then the whole square. Why is this equal? Because I get x minus x bar minus y plus y bar. But x bar and y bar are equal, so therefore they will cancel. This will cancel and you get x minus y, so they are equal. I may not have said that earlier, but you can see. Now, if you have divided by n, you divide by n, and then you have divided by n here. But that further thing becomes summation x minus x bar square divided by n plus summation y minus y bar square divided by n, and you have minus 2 times summation x minus x bar into y minus y bar divided by 2n. Sorry, by n. Why should that be 2n? That's what you get. And this is your summation d square by n. So what you get now is, finally you will get this expression. So that's not difficult. What you get now is you get summation d square divided by n is equal to, you get sigma x square plus sigma y square minus 2 times summation you get x minus x bar into y minus y bar divided by n. This is what you have. What you do is you divide here, and first of all this becomes 2 times if you cancel this, because they are equal. You put a sigma x here, this is what you get. Now you divide here by sigma x into sigma y. Here you divide just by sigma x square because sigma y they are equal, that's the same as dividing, and here you divide by sigma x into sigma y. Now you may say I have divided different thing here and a different thing here. They are not, because you know sigma x into sigma y, and sigma y is same as sigma x, therefore this is same as sigma x square, also same as sigma y square. Yeah. So this therefore what happens is this is same as summation d square divided by n times sigma x square is equal to, this becomes 2 minus 2 times this guy is actually rho. That is actually rho because that is covariance divided by sigma x into sigma y. That's how I started. I started rho, which is same as R, which is same as covariance divided by sigma x into sigma y. But this we denote by rho because these are ranks. It's called the rank correlation coefficient, but it comes in a different form, slightly different form, but it's still the Carl-Pearson's, but this has a special name. It's a special case. Now what happens is this sigma x square you substitute, here it is, oh this is sigma x square, I'm sorry that was sigma x square, sigma y square, that is going to be summation d square into n square minus 1, and 12 goes up, and this is going to be 2 minus 2 times rho. Therefore you get 6 times summation d square divided by n square minus 1 is equal to 1 minus rho, and therefore you get rho is equal to 1 minus 6 times summation d square divided by n square minus 1. That is the rank correlation coefficient. So now we can solve one of the problems and see how to use this formula when ranks are repeated and when they are not repeated. When they are repeated, so this is the formula when the ranks are not repeated. This is the formula for ranks are not repeated. And when they are repeated, you will see the formula changes a little bit. The formula changes a little bit when the ranks are repeated. So, good. Let me give you one of the problems. When ranks are not repeated, right? Yes, of course, right. Take down any problem, but let's do it. Let's do it. Let's do it. Let's do it. Let's take some ranks. Let's take a simple problem so that calculations don't give me a headache. Compute rank correlation. Pertaining to marks, that's exercise 1, to marks scored by 5 students in math and stats. Okay, marks. in math. Marks in stats. Okay. 39, 65. 5 students are there. Let's say serial numbers are given 1, 2, 3, 4, and 5. A very simple data. 62, 90, and 82. And here it is 47, 53, 58, 58, 86, and 62. Yeah. So we need to write ranks. The ranks are not given. We need to write the ranks. Okay. So ranks in math. Ranks in math, that I will denote as X. What is the highest rank? Highest marks is 90, second highest is this, first, second highest, third highest, fourth, and fifth. Good. What about the ranks in stats? Ranks in stats likewise can be written so very easily. The ranks in stats would be highest is this, highest is 1, second highest is this, 2, third highest is this guy, 3, fourth is this guy, and fifth is the same, this guy. This is your Y. Now D you are going to write as X minus Y. There's not much data involved here. D is going to be 0, minus 1, 1, 0, and 0. D square is going to be, zero, 1, 1, 0, 0. And summation D square we require. Summation D square is going to be 2. N is already 5. N is 5. What is the formula now? Let me wipe this side. The data, which I don't need at all. So, rank correlation. That is square plus rank correlation is 1 minus, that's equal to rho denoted by 1 minus 6 times summation D square divided by N into N square minus 1. That's going to be 1 minus 6 times. How much is summation D square? Is 12. What is N? N is 5. 5 square is 25 minus 1. And that's going to be equal to 1 minus 12 divided by 5 times 24. That's going to be 1 minus, this calculation is quite simple, it's 1 by 10, which is 0.9. And that completes, that's a strong correlation, positive correlation. That completes the problem. We'll do some more problems tomorrow. Let's call it a day now. Thank you so much.